I'm Dustin, and I just moved here from Seattle literally yesterday, so apologies for the jet lag. And this talk is about some open source software called ABStreet that I work on with some collaborators listed here. So ABStreet is a OpenStreetMap based traffic simulation, or at least that's how it started. And we're looking at downtown Seattle. The travel demand data comes from a local authority in Seattle. But these are different vehicle types and people walking and biking around the city. And if we zoom in this area here and slow things down a little bit, we can see a lot of detail that we can derive from OpenStreetMap. So for example, you see detailed lane configuration. And here, there seems to be a traffic jam at these two traffic lights because the traffic light timing actually isn't coordinated because traffic light timing doesn't exist publicly. But anyway, this is an agent-based simulation, so we could follow each of these cars individually and kind of study whatever we want about them. And then the neat thing you can do in ABStreet is say, I don't like how this street looks. Maybe I know that there's a bus that gets stuck in traffic. So we can take this and transform this lane into a bus lane. And then the same thing on the other side and apply the changes kind of to the whole section of the street. And then we could run the simulation again. And then if it's kind of well calibrated, figure out if the public transit can have better frequency and get stuck in traffic less often. And so all of this is sort of meant to be done by cycling advocacy groups and people without civil engineering expertise. And so by making the software really visual, the goal is to get more people involved in transportation planning. And so I'll show you a second tool. So this is work that started only about a month ago. It's really rough, but it's meant to be a tool for planning low traffic neighborhoods. So this is Central Leeds, and I'm going to focus on this neighborhood bounded by a few major roads. And so the color patterns show you where the reachability based on driving. So from the yellow area, you can't drive anywhere to the blue and vice versa. But you'll notice that the blue area covers a fair bit, and so it might be possible to cut through the neighborhood rather than take major roads, and this could be a problem to people living there. So we can place interventions, for example, and with just two modal filters there, sort of split the blue area up so that you can't really cut there anymore. And then with this tool, we can also measure the impact on routing. So for example, let's say somebody's trying to drive a really short trip kind of from the north here to just south of the neighborhood. The optimal path actually has them take major roads already, but this is sort of an assumption that isn't true outside of free flow traffic. So we can kind of adjust the weighting, and if the arterial roads are backed up a little bit, they are incentivized to cut through the neighborhood, which could be a problem. And so that's what the blue line shows. And then the red is sort of if we don't add any modal filters, or if we do add the modal filters, this is how they'll have to cut through instead. And yeah, so just a little bit about these tools. Everything is open source. And because it's written in Rust, all of this software runs locally on your laptop a lot faster. But it also runs in the web browser completely locally. Like once you sort of download the files, you don't have to hit the network at all for it. And yeah, I'm hoping to continue this work forward and find ways of incorporating it in whatever research people want to do. Sort of with the goal of developing car-free cities and involving more of the public in transportation planning. Thanks.